Welcome back, dear students. Today we'll be learning how to solve a differential equation. Now, in your syllabus, there are three different kinds of differential equation. Okay, so the first kind of differential equation is known as variables separable. Next is homogeneous equation, and the last one is linear differential equation. We will learn each type once at a time. Okay, we will give time to each of them in order to understand them well. Right, so the first kind of differential equation is called variable separable. So today we will be learning about it. Now, before we find the solution of a differential equation, I would like to mention that there are two kinds of solutions. Okay, so first kind of solution is called general solution. Okay, and the second kind of solution is called particular solution. Okay, now what is the difference between them? That's what I am going to talk. Now, when you solve a differential equation, that time you have to make use of integration. Okay, so in today's class I'll be making use of the integration that we have learned till now. Okay, now when you apply integration, again there are two kinds of integration. Now one is called indefinite and another is definite. Now if I ask you what is the difference between them, here you will have constant, but here you don't have the constant c. Okay, similarly in general solution, what you are going to do is you will be making use of indefinite integrals in general solution, which contains constant of integration c. So basically in general solution you will find c being present, and in a particular solution you will be making use of definite integrals, and here we don't have any constant, so there will be no constant in particular solution, whereas in general solution you will contain a constant c, which is constant of integration. So that's the only difference. Okay, so in today's class I'll be teaching you how to arrive at the general solution. Okay, we'll take time, we'll do it slowly. So the first question, I've written some answers also, okay, for the reference. So find the general solution of each of the following. So here, as the name suggests, it is variable separable. That means you will be able to separate x in the left hand side or right hand side, wherever you place. If you place x in the left hand side, all the y's should go to the right hand side. Okay, so in this case, let's see how to do the separation. So keep dy out here. Now here the term containing y is this one, cot y. So bring it out here. So you get divided by cot y, isn't it? And here we have cot x. Now bring this dx out here, you get dx. Okay, now can you write this 1 by cot y as tan y? Yes, so you get tan y dy is equals to cot x dx. Okay, now after you arrive at this, see, in the left hand side we have y's and in the right hand side we have x. So after arriving at this, you have to integrate both sides. Okay, so integrating both sides. So let's see how much do we get. So in the left hand side we get integral tan y dy is equals to integral cot y, cot x dx. Right, now all of you know what is integral tan x. Okay, integral tan x is, all of you know, it is integral tan x is how much? Integral tan x is log sec x, isn't it? Log sec x. You have got the formula with you for integration, you can make use of that. And what is integral, cot x? Integral, here I have to write y, no? It is integral tan y, no? So that's why it will be log sec y is equals to, how much is this? Integral cot x is log, how much? It is log sin x. So this is the formula. Now all of you know since we are done with the integration, what you can do here is we'll put the constant of integration. Now since you have got log here, you can put the constant of integration to be log c. Okay, so where log c is the constant of integration, that you will write by yourself. Okay, now we have log, see here carefully, sec x, can I write this as 1 by cos y? Obviously. And you have, this is log a plus log b. Log a plus log b is how much? It is log, this is log a plus log b is log ab, isn't it? So it becomes c sin x. Okay, now remove log and log from here. You get, what do you get? Let me write it here. So you get from here 1 by cos y is equals to sin x, c sin x. Okay, so bring this out here and bring c down there. So you get 1 by c equals to sin x cos y. Now just see what is the solution that I got here. I got sin x cos y equals to a constant, and 1 by c is also a constant. So that's why instead of 1 by c, what you can do is sin x cos y is equals to, see, 1 by c is a constant, and we will represent 1 by c by another constant, you say k. Okay, so this will be the solution of this particular differential equation, right? So it's easy. So only thing is you should know the concept of integration in this case, right? So you may pause the video and note down your first solution. Let's move to next question. So again we'll keep first dy in the left hand side, and the rest will be sent to the other side. So keep only this much out here. You get y square root of 1 minus x square dy. Now when it goes out there, it becomes minus x root over 1 minus y square dy, right? Now what will I do is, I'm sorry, it is dx, right? It's dx. So what will I do is, here I'll keep only y. So we have y dy. Bring this root over 1 minus y square to the denominator. Root over 1 minus y square came to the denominator. Here we have minus x dx left. Okay, now bring this root over 1 minus x square to the denominator. Okay, now integrating both sides. So integrating both sides. So let's see how much do we get if we integrate both sides. So you get here y dy by root over 1 minus y square is equals to minus integral x dx by root over 1 minus x square. Now if you observe here, both the integrals are same. So if you integrate any one of the integral, then you will get integral the answer for other one also. Okay, so what am I going to do is, I'll just evaluate this. We will get the answer of this in the same way. Okay, so if I ask you what kind of integral is this, then this is integration by substitution. So let's do the substitution then. So let 1 minus y square is equals to t. So from here you arrive at minus 2y dy is equals to dt, and from here you get dy is equals to minus y dy is equals to minus half dt. Let's substitute. So therefore we have the given integral y dy by root over 1 minus y square. Okay, so y dy is minus half dt. Minus half being common can be kept outside integral sign. So we have dt in the numerator. So in the denominator you have root over 1 minus y square is t. So basically this is how much? This is minus half integral t to the power minus half dt, right? So all of you know this is minus half t to the power minus half plus 1 divided by minus half plus 1. Now minus half plus 1 is half. This entire thing is half. So this half and half gets cancelled. Okay, so that part I am not showing. So this is half and this entire thing is also half, they will get cancelled. So this is t to the power half, that is root over t, isn't it? So that's why I'll write this as minus root over t, which is nothing but minus root over, what is t actually? T is 1 minus y square. So this is the value of this particular integral. Okay, similarly we can show that, see, if I take this x dx by root over 1 minus x square, then see, look at this and look at this, both being same, only thing is here in place of y we have x, so that's why its answer will be equals to root over 1 minus x square. Now substitute the value of this and this in equation, or let me call this to be equation number 1. So equation 1 becomes okay, right. So all of you know, you will get constant of integration here also you get constant of integration. So you call this as k1 and call this to be k2. Okay, so from 1 you get, instead of this, let me write minus root over 1 minus y square plus k1 is equals to, here we have minus, okay, so alright, so we have minus this one, right? So in place of this we have this much. So when you place, alright, so let me write it fully. So you get 1 minus x square plus k2. Okay, now open the bracket, you get minus into minus plus, you get minus k2. So bring that minus k2 out here, you get k1 minus k2, you bring it out here. So this becomes, there is a minus, this becomes plus. So basically what will you get? You get root over 1 minus x square plus root over 1 minus y square equals to k1 minus k2, and in place of k1 minus k2 you can write another constant, that is constant c. That will give you the answer out here. Okay, so you may pause the video and note down your solution. Let's see this particular question. So here, first and foremost, what will I do is, I'll take the common things. Okay, so we have, right, so x square is common, I see x square is common here, you get 1 minus y dy, plus here also you have y square common, so you get 1 plus x dx equals to 0. So bring this dx to the right hand side, you get x square 1 minus y dy is equals to minus y square into 1 plus x dx. Okay, now what shall we do? Let's bring this minus y square here. Okay, now if I bring minus y square out here and x square down there, so you get 1 minus y divided by minus y square dy is equal to here you get 1 plus x divided by x square dx. Simple. Now better open the bracket. So when you open this, you get minus 1 by y square. Okay, just wait a minute. Okay, so you get minus 1 by y square dy. Minus and minus gets cancelled, so y by y square is 1 by y dy is equals to, similarly you get 1 by x square dx out here, plus you get 1 by x dx. Okay, integrating both sides, let's see how much do we get. So can I write this as minus integral y to the power minus 2 dy? Obviously. Can I write this as integral dy by y? Obviously. Similarly, this can be written as x to the power minus 2 dx, plus this can be written as integral dx by x. Simple. Now this is, okay, let's look at this. So minus y to the power minus 2 plus 1 divided by minus 2 plus 1, this is log y, this is x to the power minus 2 plus 1 by minus 2 plus 1, plus this is log x. Okay, now look at this. How much is this? This is exactly equals to y to the power minus 1, and divided by we have minus 1. So minus into minus becomes plus. See here carefully, minus 2 plus 1 is minus 1, minus into minus becomes plus. So can I write this as y to the power minus 1, which is 1 by y? Yes, I can write that. Plus we have log y is equal to, similarly this can be written as minus 1 by x plus, you can write log x. Okay, so bring it out here and bring it out here, and one more thing that you can do here is you can put a constant of integration. Okay, so let me put it out here. So we have plus c also, remember. So okay, so it's okay, you keep it like this only, right? So when you bring it out here, you get 1 by x plus 1 by y is equals to log x minus log y plus constant of integration. And from here, how much is this? Log x minus log y, it is log a minus log b is log a by b. So that's why you get here, so we have log a by b plus constant of integration is equals to 1 by x plus 1 by y. This answer and this answer both are same. Okay, only thing is you have placed the constant of integration in the other side. Okay, so this is how we need to do this. So pause the video and note down your solution. Let's look at this question then. So we have again, right, so this time let's keep dx in the left hand side. Okay, so it's your choice. Okay, so we have sec square x tan y dx is minus sec square y tan x dy. Okay, so let me bring all the x to the left hand side. So you get sec square x by, you get this tan x comes to the denominator. Okay, so you have dx out here is equals to minus, here you have sec square y and this tan y goes to the denominator. Okay, and here we have dy. Now all of you must know that sec square theta can be written as 1 plus tan square theta divided by we have tan x dx. Let's do the same thing here also. So we have 1 plus tan square y by tan y dy. Okay, open the bracket, so you get 1 by tan x. Okay, so you get 1 by tan x dx plus you get tan square x by tan x dx. You can do the same thing out here. So you get 1 by tan y dy, minus into plus is minus tan square y by tan y dy. Okay, see, this is simple. This is 1 by tan is cot, so it is cot x dx. This and this gets cancelled, so it is plus tan x dx. Similarly, this becomes minus cot y dy, and here it becomes tan y dy. Now integrating both sides. Okay, integrating both sides. So what do you get? You get, see here carefully, so it becomes integral cot x dx plus integral tan x dx is equals to minus integral cot y dy minus integral tan y dy. Now all of you know the answers, isn't it? Like what is integral cot x? It is log sin x. Okay, so it is log sin x. We have next integral tan x is log sec x. Okay, is equal to, we have minus log cot y becomes sin y minus we have log sec y, isn't it? Log sec y, and you can write the constant of integration to be log c, and that's okay, right? Okay, so this can be written as, how much is this? So when you simplify this, how much it becomes? So it becomes sin x, okay, so it becomes log a plus log b is log ab, that is log sin x sec x. Similarly, this becomes minus log sin y sec y, okay, plus log c is always there, and this becomes, what is sin, see, sec theta is 1 by cos theta, so it becomes sin theta by cos theta, which is tan theta, isn't it? Sin theta by cos theta, when it goes to the denominator it becomes cos theta, sin theta by cos theta is tan theta. So basically this is how much? This is log tan x, so log tan x, and similarly this, wait a minute, so this log tan x is equals to, this is minus, so bring it out here, it becomes plus log tan x, I'm sorry, log tan y this time. So log tan y is equals to, how much is left? Log c is left. Now log a plus log b is log ab, that is log tan x tan y is equals to log c. Remove log and log, you get tan x tan y equals to c. That is, this particular answer will be arrived. Okay, so you may pause the video and note down your solution, and please do the last two steps also. Let's take the last question for today. So question says, first and foremost, let's, okay, so by the way, do we need to separate them, separate the variables out here? No, see here already all the y's are in the right hand side and all the x are in the left hand side. So just open the bracket then. So we have x e to the power x plus x dx, y e to the power y d, I'm sorry, just wait a minute, I need to write dx also, no, plus x dx is equals to y e to the power y dy plus e to the power y dy. Okay, right, so now we just need to integrate. So integrating both sides, okay, so you get integral x e to the power x dx plus integral x dx is equals to integral y e to the power y dy plus integral e to the power y dy. Okay, right, so let's start integrating then. We just observe this and observe this, both look similar, and we have to make use of what? We have to make use of integration by parts here. This x comes in the algebraic function and this comes to the, you know, this e to the power x comes in the exponential function. Okay, so this algebraic function has to be differentiated, isn't it, in case of algebra, in case of integration by parts. Okay, so all of you must be remembering in this rule, whichever comes from that has to be differentiated. Here algebraic is coming front, so that's why it has to be differentiated. Okay, so that's why we have here the rule says, okay, so here the rule says that keep it as it is. Okay, so keep the one which has to be differentiated as it is, integrate the second function. Okay, so we have this much minus integral d by dx. See here in this case what you need to do is we will write d by dx derivative of x, okay, into integral of the second function. What is the second function? It is e to the power x dx, and we will put one more dx. So this is the integral of only the first part. Okay, do not get confused. So use integration by parts here, you get this much. So plus integration of x is x square by 2. So there is no problem with this. Is equals to, similarly this is going to be similar to this. So just write y integral e to the power y dy minus integral of d by dy, this time d by dy, because the variable is y here. So d by dy of y into integral of e to the power y dy dy. So this is the integration of this much. Now what is the integration of e to the power y? It will be e to the power y only. Okay, right. So let's simplify this then. So it is x e to the power x minus, this becomes 1, similarly this also becomes 1. So this is integral is there. So integral e to the power x is e to the power x. So we have this much plus x square by 2 is equals to y e to the power y minus, similarly this is e to the power y dy plus e to the power y. Okay, now we are almost at the end. So this is e to the power x plus x squared by 2 is equals to y e to the power y minus, how much is this? This is e to the power y plus we have e to the power y. Now you can put constant of integration, as we are done with the integration here. This and this gets cancelled, isn't it? So from here you can take e to the power x common, you get x minus 1 e to the power x plus this is x squared by 2 is equals to y e to the power y plus c. So this is the answer for this particular question. Okay, so with this we close for the day. Thank you very much.